All right, we're defining and evaluating logarithmic functions. So the first part of today, we're going to talk about just how a logarithmic function is the opposite of an exponential. So exponentials and logs are opposite of each other, which means if we were to take their graphs and fold it along the dotted purple line that I'm sure you guys can barely see, but it goes through this axis, it's a diagonal. We fold the pink over on top of the purple or the blue, they would line up. So they are inverses, it's how we undo each other. And remember, we talked about inverses. Inverses have the domain and range flip from each other. So here the domain is going from negative infinity to positive infinity. The range is above 0 for the pink, but with the blue, the domain is to the right of 0, so the domain is greater than 0, and the range goes forever, so it keeps climbing slowly up and it keeps dropping down. The table of values are also flipped. We will use exponentials to derive the table for a logarithmic, and we'll do that when we learn to rewrite them, and that's what we're going to really practice today, but I want to talk a little bit about the similarities and the differences. So, again, table of values for an exponential, if we flip it, we'll get the table for its logarithmic inverse. We graph them. This is a exponential. This is a logarithmic. This is reverse domain and range from each other. And we're going to talk today and practice today. It's going to be short notes, but it's going to be very important notes because we're going to talk today about changing from exponential to log and log to exponential. And again, I'm going to be very picky about how you do this because I know that when you do it this way, it's going to stick into your brains. So the example we looked at was on the graph. Over here was 2 to the x, and this was the example of log base 2 of x. And we're going to practice going back and forth. So here's our rule. B to the x equals a, which is log base b of a equals x. And I know that sounds a little bit confusing, but I promise it's really not. And I tried to color-coded things just a little bit to help you out. So b has to be greater than 0, and it can't be 1. So here is our practice. We're going to change 4 to the third power equals 64. We're going to change that to a logarithmic. The rule says it's b to the x equals a. So b is our 4, x is 3, a is 64. When we rewrite that, we write it as log base b. So this would be log base 4, because b is 4, of a of 64 is going to be equal to x, 3. So again, it's just it's the same values, but it's how you're placing them and how you're counting. Basically, this says we're counting by 4s 3 times to get 64. And it's a fancy way of counting. I have a video that we're going to watch that's going to talk about fancy counting, give you a new perspective on math. So here, going the other way, we're starting with a logarithmic equation. We want to write it as an exponential. So we start with our basic. Log base b of a equals x. So that means that b is 5, a is 1 over 25, and x is 2. So here it says take your b value of 5, raise it to your x value of 2, and I take that back. That should be negative 2. I have a slight error. I forgot to write the negative. And that equals your a value of 1 over 25. And if you think about it, that negative flips it over, so it becomes 1 over 5 squared, which is 1 over 25. We're going to practice another one. We looked at the graph just so that we can get an idea of what it was, but we're not going to be using necessarily the graph at the beginning. We're just going to practice writing back and forth because this is really, really important. We will get to graphing them. So this says b of x equals a. So 2/3 to the p value equals q. So remember, it's about identifying what's what. So we have the log base b. b is 2/3. Our x value is p. Our a value is q. So we rewrite this as a logarithmic. It's the log base b, so log base of 2/3 of a. A happens to be q. equals x. X is our p-value. So we're going to practice this over and over and over because it's really important to doing everything else.